Evolutionary operator, EvO. Why current computation is no longer enough, and what EvO changes, English voiceover script, Chapter 12 to 15 minutes. The world today is not limited by a lack of computational power. It is limited by a lack of meaningful, realizable results. We have supercomputers, massive parallelization, cloud infrastructures, GPUs, artificial intelligence, and large language models. We can generate enormous solution spaces, simulate highly complex systems, and optimize almost anything. And yet, we repeatedly reach the same point. Results look correct, plausible, and numerically stable, but they fail in reality. Most current technologies, whether classical numerical methods, optimization, simulation, or machine learning, share one fundamental assumption: that reality can be sufficiently approximated by a good enough model. As systems grow more complex, this assumption breaks down. In quantum physics, advanced materials, energy networks, biological systems, space technologies, or in the interaction between AI and physics, we encounter the same limitation. There exists a vast number of states that are mathematically possible, numerically stable, and even optimal, yet can never exist in reality. Current computational paradigms cannot properly represent non-realizability. They can only rank approximations and choose the best among them. Large language models amplify this problem. They are extremely powerful generators of possibilities, hypotheses, and structures, but they are not causally bound to reality. The more capable they become, the more convincing and dangerous unrealizable outputs can be. What the world is searching for today is not faster computation. It is a way to separate what can exist from what only looks correct. This is the problem that gave rise to EvO. EvO was not created as another algorithm, optimizer, or simulator. It was created to answer a question that current computation cannot even ask. Does any realizable state exist under these conditions at all? EvO does not begin with equations. It does not begin with a model. It does not begin with a chosen mathematical framework. EvO begins with constraints of reality. Its computational core does not force a problem into predefined mathematics. Instead, EvO determines which mathematical structures are admissible for a state to exist. Only from this determination does it follow whether numerical computation makes sense, matrix representations emerge, variational behavior is required, evolutionary dynamics dominate, or quantum-inspired descriptions become necessary. For this reason, EvO is not a one-sided elimination engine. The elimination of unrealizable states is a consequence, not a goal. EvO's core is hybrid in a deeper sense, not because it combines many algorithms, but because it does not separate mathematics from the reality of the problem. In traditional computation, humans must choose a model, a method, an approximation, and tolerances in advance. EvO transfers this responsibility from the user to the computation itself. This has profound consequences. EvO can legitimately end in three ways: by realizing a stable state, by realizing a family of states, or by realizing nothing at all. All three outcomes are valid. The ability to correctly produce no result is precisely what modern computation lacks, especially in a world where systems are expected to always produce an answer, even when they should not. Because of this approach, EvO can be applied in domains that were previously extremely difficult or practically inaccessible. Quantum simulations, tunneling phenomena, state collapses, phase transitions, and high-dimensional energy landscapes. Not because EvO is a quantum computer, but because it respects the same principle of realizability that governs quantum mechanics. EvO therefore acts as a missing layer between generative AI, classical computation, and physical reality. And this is why EvO makes sense as an accessible service, and in the future, even as a mobile application. Not because a phone contains quantum hardware, but because quantum-inspired computation is not defined by hardware, but by how reality is treated in computation. EvO allows research into future technologies to move beyond a handful of laboratories to anyone who has a question and wants to know whether an answer can truly exist. EvO is not a system that promises solutions. EvO is a system that restores responsibility to computation itself. Free testing and hands-on access. Closing section. EvO is not a closed or theoretical concept. The EvO core can be tested for free at https://josapi.deutrino.eu evo-demo. You can directly access a public demo interface and submit any complex computation, state, process, or simulation, define tasks using equations, structured data, or physical descriptions, or simply describe your problem in natural language. An integrated EvO AI demo helps you formulate the task correctly, automatically create a suitable computational assignment, submit it to the EvO core, monitor the computation in real time, and optionally receive the results by email once the run is completed. After the computation finishes, the AI can explain why a state was realized or why it could not exist, help interpret the results, and support applying them back to your original problem. This makes it possible to experiment with classical and advanced computations, complex simulations, and quantum-inspired models and simulations that were previously accessible only to specialized research environments. EvO does not replace human thinking. It ensures that computation itself cannot contradict the reality it is meant to describe.